Hello guys, good afternoon. Dengar tak? Kalau dengar bagi respon. I think should be dengar because I open juga dekat my phone, so I just hear my voice. Okay, good. Good afternoon everyone. Have you guys punya lunch today? I belum lagi. Alright, so my name is Alif Aiman. I from Department B1, Tekom Shah Alam. So for today topic, hi everyone, hi Hasbul, hi Alip. Oh, sweet and sound. Thank you, Sim. Thank you, Jaja. Hi, Joan. Hi everyone. Hi Ivan. Hi Dayang. Okay, thank you guys. It's the last week of December and also the last week of 2020. Okay, see what we have. So as you guys know, today I will give a presentation on actuator types and selection guide for part 2. On the previous session, it's already covered by Donald, so I will continue a bit lah on this. Merry Christmas, Happy New Year, and also Happy Holiday lah for those staff yang dah holiday kan. Okay guys, without wasting any time, let's go on the summary. So as for today, I will give a little introduction to valve actuation, and also we will see on actuator types, which we have hydraulic, pneumatic, and also electric actuator. And the last part for today, we are going to see on the parameter that affect on actuator selection. So let's move on to the next slide. Okay, introduction. What is actuator? Anyone know what is actuator? I think most of us here know what is actuator. So we're just going to do some revision for today. So an actuator is a machine or component installed on the top of an industrial valve for automatically moving and controlling the valve. So basically we want to remove the manual to automatic, and also we want to control the valve as well. So actuator are used in the plant more than before to provide better and more precise control on the valve operation. So valve actuator can be defined simply as a black box with a receiving signal or power supply through air or oil pressure that produce torque for valve movement. So valve movement is under output. Oh, okay. So basically, the quality of the valve is depend on the many parameters such as the metallurgy, the mechanical strength, machining, and others. So how we want to know is it the performance of the valve, which is largely depending on the actuator. Okay, how to define actuator types? In general, we have three types of actuator. The first one, we have hydraulic, pneumatic, and electrical. So these are the source of power actually. So we see on the hydraulic first. A hydraulic actuator is a cylinder that works with hydraulic power and convert it to mechanical work. So hydraulic actuator can be quarter turn, as you guys can see in figure 1, which are used for ball valve, or linear, which are selected for linear valve such as float valve. So okay, so these are the working principle. So for high pressure oil in pressure range between 160 and 200 bar, for example, enters the cylinder of the actuator, pushes the spring back and transfer the linear movement to quarter turn, 90 degree. Movement through scotch and yoke. So basically, the mechanism of the scotch and yoke is we are converting linear to rotary. So figure 2 shows the linear spring return actuator. So spring return is actually referring to single acting actuator, in which the piston is pushed back in the piston side through the force of hydraulic fluid entering the cylinder side. So there is no scotch and yoke in linear actuator, so the movement of the actuator piston rod that connect to the valve stem is linear. It is possible to have double acting also for hydraulic actuator as per figure 3. So utilizing pressurized oil on both sides for opening and closing. So the valve. There is no spring needed in double acting as we are we have on both sides controlling by the hydraulic fluid for the open or close position. Okay. Let's see the advantages and disadvantages for hydraulic actuator. So for hydraulic actuator, it's smaller than pneumatic actuator since oil pressure is higher than air. So less oil is actually required for moving the spring compared to air. However, the hydraulic actuator is thicker than pneumatic due to high oil pressure. So number 2, the advantages is hydraulic actuator are good choice for large size and high pressure class valve, having high force or torque requirement for operation at high speed. So it's very suitable to use for a bigger size of valve lah at side. Hydraulic actuator are more precise than pneumatic actuator since hydraulic oil is not compressible. And lastly, hydraulic actuator have a higher degree of corrosion protection compared to air or gas, which is important in a corrosive environment such as offshore. So pneumatic air it could be have a presence of moisture, so moisture can lead to corrosion. So that could be the disadvantages lah. So for that is for pneumatic. So it's good for having actuator in like offshore and so on. Okay, let's see the disadvantage. The high pressure of hydraulic fluid is complex to manage, requiring many safety and environmental precautions. So a lot of safety regulation and safety measure need to be considered if you are using actuator, hydraulic actuator. So the control system of hydraulic actuator is larger and more expensive compared to pneumatic. As mentioned by Donald before, we will have a lot of parts, components for hydraulic actuator. We're going to have a motor, and a reservoir and so on. So this require more space. So for compact area, these are not recommended. Okay, so sampai setakat ni, as anyone have any question for hydraulic actuator? I hope you guys understand. This are very today we're gonna have a lot of theory and example just to allow you guys to have more understanding on actuator. Okay, so let's move forward to pneumatic. So basically, pneumatic actuator are simple mechanical device that convert the air pressure to mechanical works. Pneumatic have a same principle actually with hydraulic. The difference is just the medium. Instead of using oil, we're using air for pneumatic. So for pneumatic, it can have either linear or quarter turn. Okay, advantages and disadvantages for pneumatic actuator. So for pneumatic actuator run on compressed air, which is readily available, safe, fluid, and environmentally friendly unlike oil. So they could be the best option in hazardous area. So the control system of pneumatic actuator are relatively inexpensive and more compared to hydraulic actuator. So we have in the mid-range lah. We are not going to use a lot of expensive instrument. This actuator provide high-speed operation and returning to a safe position in case the air power source is lost, unlike electrical actuator. So basically, in hydraulic actuator and also pneumatic actuator, we can have the fail-safe mode, either fail-safe open or fail-safe close. So it depending on the location and also depending also on the application lah. Electrical actuator we don't have, but we have a solution for that. We will see this on next slide. First, we see disadvantages. So I have mentioned before, the presence of moisture could jeopardize the accuracy of the pneumatic actuator and also could lead to corrosion. Okay, let's see on third actuator type we have for electrical. An electric actuator in the valve automation fields is a device that convert electrically generated to drive the valve. So we have electric to drive the valve actually. So how does it work? So we will go and see on that. Electrical actuator, as per figure 5, use electrical power for actuation of the valve. In fact, electric actuator are geared motor with different electrical accessories such as a limit switch and circuit board. Everything is inside the actuator. So it comes with various motor works with 12, 24, 115 or 220 AC or DC voltage. How does electric actuator work? So see. An electric motor will create rotary motion as a spindle or rotate. The motor spindle is directly coupled to a helical screw via the drive shaft, which in turn rotate in a ball screw unit. So as the spindle rotates, the ball screw nut is driven forwards or backward along the helical screw. So it's a long word to understand, but basically if you have a screw that you're going to put into a hole, it's either you turn into a clockwise or anti-clockwise. It's going to move forward or backward. So these are the motion, these are the linear motion that will create. So it's a very basic concept lah. So a hollow piston rod is attached to the ball screw nut and this create the linear motion moving out or into the actuator as the motor rotate clockwise or anti-clockwise, as I mentioned before. Okay, see, in basic mechanical electric valve actuator types, the motor is stopped at the desired position when cams mounted to the actuator output drive shaft make the mechanical switch. So there is no fail-safe mode for electric actuator, but we could have another way. So without electrical power, the electric actuator cannot move and will stay put. So see, a fail-safe electric actuator has a way of driving the actuator to the desired fail-safe position when external power is unavailable. There is two basic way of achieving fail-safe functionality. So number one, store electrical energy that can be used in place for the external power to power the motor. And number two, we have store mechanical energy to physically drive the gearbox independently from the motor. So depending on the application, we can use either of these two ways to achieve our fail-safe mode. Okay. Let's see the advantages and disadvantages for electric actuator. Okay, the first one, electric power is relatively inexpensive. Electric actuator provide good accuracy of valve movement and functioning, and it's possible to monitor the opening and percentage of the valve. Comes with good accuracy. All control components are integrated into the actuator, unlike pneumatic and hydraulic actuator. So basically, like pneumatic, you're gonna have filter regulator, you're gonna have SOV, you're gonna have positioner, and so on. This is for the controlling. And for, let's say, for on and off, you're gonna have on top of it ada limit switch, but still we still require AFR and so on. For hydraulic, kita ada dia punya control board. It's very bulky, it's a control board and require a lot of space. So for electric, they are more compact, cheaper, and lighter than pneumatic or hydro actuator. So disadvantage. For disadvantage, electrical actuator cannot maintain fail-safe position. Normal electrical actuator. So basically, we have to use two ways that I mentioned before in order to achieve the fail-safe mode. Number two, electrical actuator contain more complex and sensitive component compared to pneumatic and hydraulic actuator. So we have limit switch, we have circuit board. So we want to make sure that everything is okay inside lah to not jeopardize the operation. Electrical actuator are not as economical as pneumatic or hydraulic actuator above certain sizes. So certain sizes, there's a limitation lah. Okay, this is the last part for today. We're going to see there's 8 point on the parameter that we will have to consider. Number one, availability of power source. A hydraulic actuator cannot be used on a plant if no source of high pressure oil is available. Number two is depending on the torque requirement and size of the valve. So large size and high pressure valve class. Let's say we have 30-inch size plus 1500 bore valve require high torque for operation. So selection of a very large pneumatic actuator for such a large valve is not economical. So instead, we are using a hydraulic actuator is recommended in this case. So for failure mode, okay, failure mode either fail open or fail close. Pneumatic and hydraulic actuator, we have this, but electric actuator we don't have. It's not that we don't have, we have option, but we need to install the external energy or mechanical energy and so on. So if you see here, pneumatic and hydraulic actuators stand in open or closed position during a power loss. Unlike electric actuator, this type of valve are spring return, which means that upon power or signal failure, the spring return the valve to a predefined safe position. Therefore, for example, like we have electrical actuator are not suitable for emergency shutdown valve that should be fully closed if power is lost. Okay. Number four, speed of operation. Electrical actuator operate valve more slowly than the pneumatic or hydraulic actuator. So an electrical actuator may not be an appropriate choice if an operation speed faster is expected for the valve. Number five, we have frequency and ease of operation. It is common to use electrical actuators or certain large size valves that are operated frequently instead of manual operation. So for ease operation, example we have 20-inch size class 300 manual valve with a frequent operation. So it is proposed to be equipped with an electrical actuator just for an ease operation. Depending on the application and also location lah. These are the first five. Let's see. On number six, we have the control accessory. Control accessories in electrical actuator are integrated into the actuator, unlike pneumatic and hydraulic actuator. In fact, electrical actuator do not require any space for control accessories, which is an advantage. Hydraulic actuator have large control panel compared to pneumatic actuator. So for compact area, if we don't have clearance, we don't have enough space, the location requires something that compact, maybe electrical actuator might be suitable. But we have to see lah, is it capable to cope with the size, or maybe we are required a large torque which recommended to use hydraulic actuator, or maybe we use the mid-range pneumatic. So it depending, this is the consideration that engineers need to think and need to design. So for hazardous area, the use of electrical actuator in the hazardous environment may be limited in some cases. Different hazard zone and classes are defined based on presence of flammable gas or vapors that may put restriction in usage of electrical actuator. Let's see. We have an electrical actuator in the place where there is a presence of H2S or flammable gas. Let's say. So if there's any electric leakage, so this electric leakage that exposed to hazardous or flammable, gas or vapor, it could create a spark. So spark can cause of fire. So these are the things that we need to avoid at all costs. So that's why there's a restriction in the uses of electrical actuator. And last but not least, we have cost. So electrical actuator are the cheapest type of actuator. Hydraulic actuator are the most expensive, and pneumatic lie between, in the middle, for the mid range. So uh, that's all 8 points consideration parameters that affect on the actuator selection. Okay, so far anyone have any question for today? Let's see, we have come to the end of the session already. Okay, guys. Anyway, thank you for those who are watching my live today. Um, and I hope you guys have a good Monday. Um, and we will see more for other topics next year. We'll have another topic, and I hope you guys learn something from today's slide. And okay, that's all. Thank you, and take care. Bye bye.